Have you ever needed to make a decision between performance or saving costs on infrastructure, or whether to go with batch jobs or build that fancy stream processing pipeline? These aren't just technical decisions, they are business critical moves. In this video, I am going to share with you 5 essential technical trade offs that will help you level up your system design. So stick around. Hi, I'm Edna. Welcome to my channel. I help software professionals grow their skills and use AI powered tools and processes to become more productive. I've been in tech for over a decade now, and I have experienced it all: promotions, burnout, layoff, you name it, which all of that pushed me to rethink everything. So I decided to create a space and share my experience with other software professionals to help them grow their skills and also stay employable in this ever changing job market. So if that's you, hit that subscribe button so you won't miss out. Oh, by the way, make sure you stick around until the end because I have a dad joke for you. And by the way, this is part 2 of our software architecture trade off series. This is the link to part 1 in case you missed it, but no worries if you did because this part 2 stands on its own and also has been packed with valuable information. Trade offs are the hidden currency of the technical software decisions. For example, cost versus performance, cost versus reliability, batching versus streaming processes. Chances are, every good system that you've seen is filled with these behind the scene decisions. Well, you guessed it. And every bad system is because these important decisions were ignored. When I make technical decisions, here are the questions that I always ask. What's the business impact of each option? How reversible is it? Will it create future blockers? And can I decouple it and revisit it later? Here are some tools you can use to help you make those technical decisions. One, use ADR. It stands for Architectural Design Records, which helps you document the context and rationale and options that you had and what you chose. And trust me, you will thank me later, especially because it's going to save you time in the future when you're like, wait, what did we do and why did we make this decision? The second one is workshops with stakeholders to help align on priorities, like stakeholders like, product managers, designers, engineers, like people from finance team, other teams, right? I've used that personally myself before and I really like it. Another way is to prototype things, right? Like use tools like Figma or Postman or Flask to quickly create a prototype and kind of see it before you commit to it and see if it's feasible. I've tried this too, and it's been also successful. If you have enjoyed this video so far, I would really appreciate it if you click on that like button, comment, or even share. Also, if you haven't subscribed to my channel already, please go ahead and do that. It helps the channel grow and also to show this content to other people that might find it helpful. And in return, one, I will be very grateful. Two, I will answer all of your comments, I promise. So go ahead and comment. And three, here's a cute picture of my dog, Kaden. All right, let's continue, shall we? Let's go over the cost versus performance trade off. Faster and more reliable systems often mean that their operational costs is higher, right? Like the licenses, the infra. But the reality is you have to always make the trade-off, right, between user experience gains and your operational costs. Performance means how long does it take for your system to respond to a customer's request, and also how does it handle the load on it. So a key factor or keyword you might hear in this area is latency. It means that the amount of time it takes from when the user sends a request to your system and when your system responds back. Let's go over some techniques that would help with this trade-off. If your system provides and accesses data some specific data, right, that very frequently, and also they are very expensive to retrieve, you can save those close to where the user is, for example, in their browser. Another way is to use CDNs, content delivery network, which you can host and serve those static large file and images. And you basically place these CDNs in different parts of the world where it's closest to your specific audience and users. Another way is to identify those long running queries and push them to background processes and jobs. So that way you can free up your APIs so that they can respond quickly. An example I want to share with you is in the past, I was working on a project where we went ahead and moved the user permission retrieval to Redis, a in-memory caching choice. That's my dog, Caden. And we were able to cut the query performance and improve it by like 50%. Let's go over cost versus reliability. Reliability means that your system is going to continue working even if something goes wrong. I mean, don't get me wrong, right? No system is perfect and failures are going to happen. But what's important is how your system is going to handle that failure and how graceful it is. Does it crash and burn and loses data and just goes offline? Because that's not good, right? One way to kind of work with that is using a thing called circuit breaker. Yeah, just like for your house, it's like a protective switch that goes off, and basically it stops requests from processing to prevent extra further damage. And once the system stabilizes, it basically resumes those requests. I remember in one of my previous projects that we used retry logic and we also used database idempotency so that we can avoid duplicate transactions. And you can imagine for systems like banking or you're doing billing, it becomes especially important to not double charge your customers. Those and coupled with adding the circuit breaker, obviously, we were able to really provide a very resilient and stable system. Let's go over database efficiency versus query speed. Normalized databases means that they're compact, clean, and consistent. But when you're trying to query data from them, they can be slow, especially when you're using joins. On the other hand, denormalized databases are a lot faster to query from, but they can introduce redundancy and also sometimes data inconsistency. This trade off could impact your system's speed, maintainability, and scalability. So, to get ahead and around that, the recommendation is to normalize your core business data, but denormalize your read heavy operations. And you can also use read replicas and then also cache. The next trade off is batch versus stream processing. Batch processing is basically when you're dealing with high volume of data and it is okay for you to process those in the background at a scheduled time. So you can see this is actually pretty makes things simple, but also it's easier to validate it. On the other hand, the stream processing is real time, and because of that, you can get response quickly, like for live dashboards and fraud detection. But that means that you have a more complex system, and also it is harder to validate those, right? Real time. Remember, in one of my last previous projects, we were dealing with a $10 billion billing system migration, and we decided to go with the batch processing because it enabled us to do easier validation. It was better for auditing purposes and it was simpler. The fifth and last trade off that we're going to cover today is testability versus complexity. Testability basically means that in order to accomplish it, you need to have a more modular and decoupled system. So each component needs to have its own module. But this means your infra is going to be more expensive and also your system is going to be more complex. But at the end of the day, you're going to have a lot more reliable and maintainable system. Not to mention your team's confidence in doing coding and also development, and also releases, right? You can release with like fewer bugs or hopefully no bugs, and your stakeholders are just going to be happier. I remember in my one of my previous projects, we had this UI that didn't have, it was in written in React and didn't have any tests because it was very intertwined with the backend logic. So we had to convince the management. So we wrote a proposal and we decoupled those two and created like a module around each, and we were able to easily add tests, and we were able to have a lot better and more confident and good like releases with fewer like unexpected, completely like stopping all the workflows type bugs. If you like this video, I would really appreciate it if you like, comment, and share it. And again, if you haven't subscribed to my channel yet, hit that subscribe button now so you won't miss out. It really helps the channel grow, but it also helps to show this content to others who might find it helpful. And now I leave you, like I always do, with a little joke. Because life is too short not to laugh. Why did the software architect break up with the database? Because of too many relationships and not enough commits.